my name's Nathan. I'm a content creator at Xometry, and I'm here today with Ricky Willems and Courtney Hollis. They are part of the Mammoth BattleBot team, which Xometry proudly sponsors, and today we're going to be talking about the BattleBot, learning a little bit more about it and how Xometry helps them build their big ideas. Nice to meet you guys.
Nice to meet you too. Thanks for having us.
Yeah, of course. Thanks for coming.
Nice to meet you.
For those of us who do not watch BattleBots, what is Mammoth?
Sure.
Not what is a mammoth, but what is Mammoth?
So Mammoth is a 6 foot tall giant combat robot. It's 2-wheel drive with a giant rotary flipper, we call it, or sometimes called the yeeter for those at home that like to have a little fun.
Lifter flipper.
Lifter flipper. The idea is
you want to get fancy.
It's a robot that goes into arena, throws other robots around, and tries to win a match either by disabling the opponent or getting them outside of the arena so they can't continue to fight.
Okay, all right. What was your inspiration for this big flipper bot?
Mammoth was inspired mostly by the kind of things I watched on TV when I was a kid. So two of my favorite robots were a lifter robot called Biohazard and a giant spinning robot called Nightmare. And I sat around thinking, well, I want to build a new robot. I want to build something interesting. Maybe I will take the idea of a lifter and see if we can make that new again. They'd kind of fallen out of style. I was like, how can you make a lifter interesting? Well, what if it just keeps lifting? Every time it lifts, it just keeps lifting. Well, you can do that by having a lifter at the end of something that spins. So how do you make a big lifter that's capable of throwing other robots around and not getting smashed up in the process? Well, you make it really tall and you make it really wide, really long, and just kind of control the match that way. And it all just kind of fell into place.
And for context, how big is this bot?
So yeah, that's a good point. For context, Mammoth is
bigger than all of us.
Yeah.
Yes.
Yeah, Mammoth is much larger than all of us. Mammoth is the largest robot that has fought at BattleBots in terms of outward dimensions, height, width, and length. Most robots are, maybe 8, 10 inches, 12 inches tall. They're maybe a couple feet long, a couple feet wide. Mammoth is almost 11 feet long from tip to tip, and it's over 6 feet tall some seasons. So,
wow.
Yeah.
Okay. All. What are some of the strategies and tactics that you use when you are using this sort of flipper design robot?
So a lot of people don't see it coming, or they didn't anyway, our first couple of years, but our driving style and general approach to fighting the robot is completely full send. We launch into the fight as hard as we possibly can.
We're just gonna go for it.
Yeah.
There's no holding back.
No, and you can't hold back with a design like that. The robot has very little armor on it. The robot has very little time to let the opponent do what they want because we'll get smashed to bits. We need to attack them as quickly as possible, do as much damage as we can, and
sort of an overwhelming force approach.
Yeah, and with the size, it gives us this ability to kind of overwhelmingly blanket the opponent with, rapid fire hits. Team Mammoth, like many teams, we build what we can with what we've got, and it's a game of understanding your own production capabilities. And one of the reasons Xometry is helpful is they have a lot more production capabilities than we do. We have all kinds of parts on the robot from when we first started out that are cut on manual mills, manual lathes, and then we weld together. And they do an okay job. But they're not exactly what we'd like. They end up having to be heavier and take more effort. Using Xometry and having them have access to all sorts of 4-axis and more, fancy machining capabilities, we can have them produce stuff like this. It's a single piece. It's got fillets in the right spot. It's got lightweighting designed into it. This ends up saving us not only weight, but ends up making it stronger at the same time. And most importantly, it lets my team focus on the stuff that we'd really like to be focusing on, which is testing and tuning and the design, rather than the nitty-gritty of trying to machine every, individual part. Right, exactly, every last detail. Something like this, I've no doubt my team could do, but it would take us, hours and days and weeks to do. And we'd have to beg, borrow, and steal great machines to do it on. Xometry, they pick up the phone and they call the right person, and they get the right person to do it for us.
So tell me a little bit also about what material did you choose for this? What material? Did you use any finishes as well?
Sure, yeah. So this is a lightly hardened, forgive me, I don't remember the exact number we picked, but
That's okay.
it's a 4140 steel piece, so chromoly steel. And we use this all over Mammoth. There's a lot of places, basically any part that isn't considered likely to get hit is either 4130 and 4140, and it's just a good balance of strength and weight and workability. The finish, thankfully, in a lot of places on Mammoth, we're not too picky on. This is one of the few places we really care about because we're interested in reducing part count and we don't want parts that break midway through a match. We run a lot of our spinning parts without any bearings. So we call out a very tight tolerance on the shaft bore, or the bores for the shafts that fit through here. So this can ride directly on another piece of hardened steel, and that's one less bearing that's likely to crack halfway through a match or something like that. We know it won't last forever, but fights in BattleBots are 3 minutes long. As long as it lasts 4 minutes
To the end.
yeah, then we're good to go. So that's what ends up being really valuable to call out. I don't have to have one of my teammates sit here and try and hit a perfect, mirror finish down to a plus or minus half thousandths tolerance. I can have Xometry do it for me. So the design process on Mammoth never really stops. I mean, even throughout the competition, we are redesigning things that we figure out that could be better. But the timing for trying to get a robot finished between when they tell us a robot needs to be done and when it has to be done by can be as short as 6 weeks. So we need to take, it's pretty
hard.
intense. It's a little difficult.
It's a lot of long nights.
This is, for Courtney and I, this is another full-time job basically. And for a lot of our team, especially as it gets down to crunch time, just as much. I mean, 40, 60, 80 hours a week go into this. In the time between when a season is filmed and when we know another season is going to be announced, probably, we sit back and we try out new motors, we try out new gear ratios, new gearboxes, all sorts of things. And that's the time when rapid prototyping really comes into play. I mean, we want to go and as quickly as possible try out this part or that part. Doesn't need to necessarily be pretty, doesn't need to be the best thing in the world, but it has to happen now because otherwise we're going to have no time to do it later when we get into crunch time. So being able to quickly get those parts, put them into the robot and see whether or not the idea works rather than the specific implementation gets to be really important. So what's really great for us about Xometry is we are at a competition and anything happens. I mean, it is very unpredictable and we always need last minute, heat of the moment help. And Xometry's supplier network is so vast that we can go and call on people kind of day or night sometimes to get stuff done. We had a situation at this last filming where we kept having gearboxes explode. And we realized we could fix it by basically welding certain pieces together and using better steel, but it ruined the tempering on the parts. And we needed to have these heat treated, and we needed to have these heat treated like within a few hours. So I called up Xometry because they were very insistent, like any way we can help at any point, just let us know. And I was like, can you find me a place that we can drive to, from Las Vegas within a few hours that could heat treat these parts for us so we can drive back to Vegas, put them in the robot and be ready to fight first thing in the morning. And I got a call like half an hour later saying like, yeah, there's this old man, he runs a small shop. And we were able to call on them and say, please heat treat this and get it back in the robot and just be ready for the fight almost immediately. And that's the kind of thing where I'm never gonna know that this guy has a small shop outside of Reno or wherever it was. But Xometry has this network, this supplier network that taps in not just to the people around us in Baltimore, but people at filming, people that are near other suppliers that we have for other parts on the robot. And we just kind of need to know talented people, around the country, around the world that can help us out. And that network is much bigger with Xometry on our side.
Are there any other big benefits of working with Xometry?
The biggest thing is being able to get things done very quickly and very well. Usually it's a pick two kind of thing for us. We can have it done quick or cheap or well, and we can't do all of them. But with Xometry as a sponsor, we don't have to pick as often, and we can get back to building and designing and fighting the robot.
We're going to go through 15 rapid fire questions. Are you ready?
I guess so.
All right. First question. Did you both watch BattleBots growing up, and what was your favorite bot if you did?
Absolutely. Biohazard, Nightmare, Backlash.
Okay.
Yes.
3 for the price of 1.
I grew up with it with my brothers, and I don't have a favorite robot.
Okay.
Because I can't remember that long ago.
Okay. Fair enough. From your time on the Mammoth BattleBot team, what has been your favorite fight that you participated in?
Ooh, speaking of favorite robots, we convinced one of my favorite childhood robots, Nightmare, to come out of retirement for a fight against us.
Oh, wow.
Which we won. And that was kind of a just jaw-dropping moment.
That's awesome.
How about you, Courtney?
My favorite fight is the Copperhead fight.
Okay.
Mammoth came in, it broke things. I like it.
Speaking of which, what would you say is the most challenging competitor that you've ever gone against?
Tombstone?
Yeah, I mean, we fought, Tombstone is the guy that everyone shows up and says, how are we going to beat Tombstone? It's a fight that we've been asking for forever, and we finally got it, and
what made it so difficult?
They are a massively destructive robot, and we are a robot that has almost no armor. So the question was, are we going to be able to stand up to them long enough to knock them out? And we lost the judge's decision, but we did knock them out.
That actually segues nicely into my next question, which is, Mammoth is a little bit of a glass cannon. It's got a really big weapon, but it has relatively less armor compared to some other bots. How do you compensate for that when you're driving the bot, where you maximize the fact that maybe you don't have as much armor to work with as some of your competition?
For one thing, just full send aggression. If we are going to win these fights, we have to go in and get the other robot out of the arena, or get it to break itself as quickly as possible. Also, coming full speed at them means that they're more likely to break themselves, because they're going to take a much bigger chunk of Mammoth, and a lot of robots aren't designed to take a big chunk of Mammoth. What else do we do?
Well, I've also had a surprising number of conversations with the other teams that we fought, and they come up and they're like, I don't know what I'm going to do to fight you. Kind of picking the best place to attack, I think, is difficult for a lot of people, because you don't want to get right into the weapon zone, but you also do want to tear up those juicy, sweet tires.
We don't have a lot of armor, so we're going to get damaged. But the robot takes an awful lot of damage and keeps going. I mean, we can have huge chunks, like we can have entire sections of the robot missing and still be hitting someone. And I don't think a lot of people know how to prepare for that. Other robots with, a thick piece of steel or something, if that gets ripped off, like their guts are all over the arena.
Right.
And we've had the thing just held together practically by tape and foam by the end of a match, but the wheels are still spinning and the weapon's still spinning, and
Speaking of spinning, how fast, do you know off the top of your head how fast the weapon can spin?
On Mammoth?
Yeah.
Yeah. So generally speaking, we run the weapon on Mammoth at about 30 miles an hour. That's not very fast compared to some of the other robots, but there's about 12,000 pounds of force at the end of that. So we can lift and throw anything in the arena, and then some. If we really want to, we can turn that speed up a heck of a lot more, but as the speed goes up, then we're more likely to just explode ourselves.
Fair enough. I can see why maybe you would want to avoid that.
Yeah.
A little bit. Fair enough, fair enough.
It's one of the few places that we try to be a little strategic.
Makes sense. What is the weapon made out of?
So the weapon hub, the center of the weapon on Mammoth, is made out of carbon fiber. It's a piece made by one of our sponsors, and it's got big aluminum plates on the side and the sprockets assembly that bolts to it. As you go out, the big arm sections of it are made out of material called Tegris, which is a woven polypropylene material, very strong, very flexible. They use it as the underbody panels on like NASCARs and that kind of thing. And the tips are abrasion-resistant AR500 steel tips with titanium plates around the outside. And that basically is the part that we want to jam in the mouth of the other opponents and see if we can jam them up or see if we can hook them and throw them.
Okay, interesting. Now, this is a very big bot. I'm curious, how tall is this bot?
The one we brought in today is like 6 feet tall on the dot, I think.
Mhm.
The other ones we've had have been like 6'4". It's never been below 6 feet though.
Is there anyone on your team that is taller than
Matt.
the bot when it's at the...
Matt is 6'1", I think.
With good posture.
Yeah,
Okay,
if he
so-
ever-
so
he's like
one-
me.
so
if he
one
ever-
How
member
tired
is
is
out.
Matt? Is he
Okay.
just
Yeah.
like this?
Matt is taller than the robot at the
So
beginning of the
energetic
day.
Matt is
Mhm.
taller than
Not at
on
the
a good
end of
day.
the
Okay.
Yeah, caffeinated Matt, you know,
Have you ever considered making the bot taller?
We have.
every year, all day, every day. We just sent him stupid pictures where it was like, what if it did this, Ricky?
They're like, please, please. and I want to make the robot taller. I think it would be cool if it was taller. I sat back when we first designed the robot and I said, 6 feet is as tall as we can make it. After that, we're going to start to have problems. And then the next year, I was like, we'll make it a little bigger. We made it 6'4", and it broke in all the places I expected it to break. I was like, nope, 6 feet is the upper limit. We've got a weight limit to build to. All the robots had to be 250 pounds. And with the materials that we use, with the construction methods that we have, 6 feet is just kind of the peak for that particular configuration.
Speaking of that, are there any other like big design changes that you kind of dreamed up, you had in mind for it, and you really wanted to make it a thing, but it just wasn't practical to make it part of the bot design?
Oh,
I feel like there's a lot of things where we're like,
I read something about legs. I don't know if that's a
oh,
thing.
it always has legs. Oh, you mean like Walker Mammoth?
Like Walker, yes.
Yeah.
I heard something-
Spider Mammoth.
Yeah, I heard something.
yeah.
about that.
There's some horrifying illustrations out there of Spider Mammoth, and that's something I want to do. I mean, I have had in the back of my head a Walker robot for some time, and it's something that I work on a little in the background while we work on Mammoth. There's other weapon configurations. We've got all kinds of interesting higher speed weapons that we are toying around with. If we really feel like those are ready, we'll bring them to the battle box, but it's a full-time job just getting Mammoth as it stands designed and built and ready for fight.
How did you settle on the name Mammoth?
So we settled on the name Mammoth after a lot of revisions. It was actually originally named Bigfoot. We had the smaller robots that I had built of the same kind of look. Someone had just started calling it Baby Shoes, this particular robot, and I built a bigger one. I built a 30 pound instead of the 12 pound, and I started to call it Red Foreman because kick you in your butt. And I realized that the big spinning trunk was rather elephantine.
Oh.
And we had these big forks that come out of
Yeah.
front that were white that, looked kind of like tusks.
Okay.
We had a big tail coming off the back. We had these big circular things, and perhaps those could be eyeballs, and Mammoth just kind of fit. And I went to my teammates and I was like, how about Mammoth as a name? And they're like Mastodon's a much cooler name. I was like, no, guys. Mammoth. Oh my God, yes.
And a hero was born.
And the rest is history.
Then you get a cartoon and you're good.
I feel like you've already answered this next question pretty well, but do you have any other silly nicknames for the bot?
Oh, actually.
Oh, yes, every year.
Every year.
Each
Give me
individual
your top
bot
three.
receives a name.
Top 3 silly nicknames.
There's 5 new ones.
Yeah, so we just produced 5 robots for the Destructathon live show in Las Vegas, right?
All right.
Each one of these robots gets a silly nickname, and
There's a theme sometimes.
sometimes there's a theme.
Okay.
So the first Mammoth was Sporty, and then there was Ginger, and then there was Posh, and then there was Scary, and then we had Baby. So those, I think, are our most treasured names for our particular fleet of robots this year.
That's great.
They all have their names written on them too.
It doesn't seem like you have any need for this, but I do have some other potential silly nicknames for the bot.
Okay.
I have 4 that I was able to come up with, and I'm curious which of these 4 you like the most.
Okay.
You can both tell me, let me know your favorite. Number 1 is the Iron Giant.
Okay.
Okay.
All right.
Second,
Great movie.
Yes,
Yeah.
very good. Kind of sad, actually.
Oh,
But very, very good.
moving.
Tearjerker.
Yes.
Okay,
Yeah.
so good start
It's
with that
beautiful.
nickname. Second name, Flippy McLiftface.
Oh, that's an internet name right there.
Yeah.
Okay. But biggest BattleBot.
I'm just gonna veto that.
Okay.
Yes, low on
And
the
then
list.
last one is, wow, you're so tall. Do you play basketball?
We hear that.
Ooh, I like that one.
Yeah.
Yeah.
That was my nickname in high school.
Don't ever ask me that.
The robot that we brought into your office today is Betty of that particular pair that year was Betty and
Oh, Betty, the biggest BattleBot.
Well, yes.
You heard of her.
Yeah, I see you're familiar.
Yeah. Next question. What do you think is the biggest life lesson you have learned from your time competing in BattleBots?
Failing is great. You learn the most when you're failing. When you are not failing, everything's just going along great, and you're like, this is super, and like everything's just working and it's great. But when you fail, and I'm gonna be honest, it hurts. It doesn't feel good. But you learn way more because then you're finding out what your limits are, what the limits of your components are, what the limits of your robot and your design and everything else, and probably the limits of your emotional capacity. You learn way more. And people don't appreciate the wonderful things you can learn when you fail. I will admit it sucks though. Like, people are like, no, sport, it's good, don't worry about it. It's okay to feel bad about it.
Yeah, we're gonna need to go over there and feel our feelings after a fight.
Our hub broke this year and I felt really bad about it. But we learned a lot.
Yeah.
We were like, we need to let this thing cure longer. Maybe we made a mistake in the design. Maybe that's our fault.
Especially with a robot like Mammoth that is supposed to be experimental, that is supposed to be trying new things, supposed to be doing things differently. There's no way to do that without, frequent failure.
Yeah.
And there's other teams that have just had a wonderful failure arc, and those are the ones that we try to emulate with Mammoth. Of, they tried this, and like that year it worked okay. The next year it came back and it was incredible. Or they never did it again because it wasn't worth it.
Yeah, it's fine to try things and be like, you know what? It didn't work out. Okay.
Fail fast and fail well.
Yeah, then that's what robots are about. That's what rapid prototyping is about. It's what engineering and learning is about. If I can make one recommendation, see if you can fail with other people's money. Thanks, Xometry.
Yes.
Final question. Any advice for aspiring engineers, designers, hobbyists that are really wanting to get started building their next big idea?
Start small.
Start small, start fast.
Just start doing it. Start small. Don't be afraid to try and hit all of these things, or don't obsess about trying to hit all of these things, because you're never going to hit these things if you try and hit 10 big things at once. Start small. Say, I'm going to do this thing first. See what happens. Great. Start from there. Then you can move on. You can make it bigger. You can make it better. When you have something like Xometry, you can order just one of something. You don't have to order 500. Start small and build it up from there.
Be flexible with where you're going to go, too. I mean, we didn't know what Mammoth was going to look like when we started building 12-pound versions and 30-pound versions. We had a general idea, and we felt, this particular direction was going to get us to where we wanted to go, the easiest, the fastest, in the most rewarding way possible. Be ready to change your route along the way and try to get resources that can help you make those changes as you go along, and that are flexible, that can, be flexible with you.
Yeah. Well, thank you so much for coming, guys. We really appreciate it. And last final question. You're Baltimore based. Do you have any good restaurant recommendations?
Hirsch's.
Hirsch's.
Okay.
Yeah.
Sounds good.
Yeah.
All right.
Check it out.
Thanks for watching.